you.
Thank you. So I'm Babbie Dunnington. I'm the project and design coordinator for GreenThumb. GreenThumb is the division of the Parks Department that works with community gardens around the city. So thanks everyone for joining in. We appreciate you all coming in at this time, and hopefully things will be getting better, but all of our workshops in this webinar format. So please continue to share where you're from in the chat box. It's really great to see all the community gardeners who have joined us. And today we have Sara Perl, is it Egendorf? From
Egendorf, yeah.
Egendorf, Oakland College, and she talked to us about safe soils in the garden. So I'll let her take it away.
Great. Thank you, Babbie. Thank you, Anthony and Mara, who helped organize this. Thank you to all of GreenThumb, and thank you to all of you for joining. So my name is Sara Perl Egendorf. I often go by my middle name, Pearl, but any version works. And I was born and raised here in New York City, which is Lenni Lenape land, Lenape-Hoking. And I just want to take a moment to acknowledge the land that we're on here. Find yourself. And how grateful I feel to be able to study this land and soil and all the amazing work that soils and humans do together. So with that being said, we'll talk about lead in soil today. I have the chat open, so if you have questions, you can put them in the chat and I'll do my best to respond as I'm going through, and otherwise I'll save a lot of time for the end. So make sure you've got your questions. And so with that being said, here's what we're gonna do. I'm gonna give an intro, an overview of lead in soil. I wanna make a big thank you now and always to the essential urban growers everywhere, but especially essential in our cities, talking about soil, lead, environmental injustice, lead versus other contaminants, sources of lead, and then solutions for lead in soil, what you can do about it, issues and misconceptions, why it's complex, and what you can do now. So gardening in the time of COVID-19, soil testing, which is mostly on hold, but we've got a number of really important best practices that are needed now and always. So this may be a review for some of you, and but hopefully repetition is helpful. And again, happy to answer your questions. So I want to give a little more background about who I'm representing. I've been with Brooklyn College in the Urban Soils Lab there, and I've been a master's student, just finished my PhD. So I'm now a doctor of the dirt. And I've also been working with a lot of, thank you, I see some clapping. I've been working with a lot of different organizations to try to get everyone on the same page about how we deal with lead. So we've been calling this the Legacy Lead Coalition, thinking about new iterations, how we can keep expanding this knowledge and this good work. But starting in August, I'll take a job with Cornell and their Healthy Soils, Healthy Communities team, working closely with Cornell Urban Ag. So I'll be a postdoctoral researcher based in the city, hometown. So I'll be around for as long as I can be, but definitely for the next 2 years, doing this work and continuing it, trying to support all of your efforts. So thank you. I always want to start with a thank you and start with our indebtedness to all the people who are growing food, but especially now, you know, you all know this, that community gardens are this nexus of urban sustainability and environmental justice. And you all are helping promote personal, community, and environmental health. You're improving, increasing access to fresh produce, food sovereignty, physical activity, space for community building, use of abandoned lands, reducing waste, and improving air and water quality and many different ecosystem services. So this is important now and always, and we thank you. You're also helping limit the legacy of lead. Whether you know it or not, urban gardeners have been helping to build soil that deals with covering the contaminants we have. So what you see here is a map that is not a systematic map of lead in soil, but these are samples that were sent into the lab at Brooklyn College. And every area in red is a Census Bureau area where the middle value of the sample sent in was above 400 parts per million. So there are these standards set forth by the EPA and our state Department of Environmental Conservation that looks to 400 parts per million as a safety threshold, which was also developed for young kids playing in bare soil. But it's important to know that naturally occurring soils without, human impact on average have 20 to 60 parts per million. So we have this green areas here. If it's below 150, that's very good for an urban area. 150 to 399 is, in between, and then 400 and over, we want to exercise some caution. This is common in New York and many other places. And I love to point out that even 36% of New York City's surface is covered with soil. We've got a lot of soil in our fine city. And even though this isn't a systematic map, as I mentioned, there are many, it's very, very common to see concentrations of lead above 400 parts per million. Lead, as I'll talk about more, can't be broken down or effectively removed from soil. It's an element. This puts people at risk, not just gardeners, all urban residents, and especially kids who are far more vulnerable to the consequences of lead exposure and neurotoxicity. But gardeners have been building new soil, which limits exposure and dust for generations. And so more knowledge on this can help us work together to address this issue. I also want to point out that this is a map put together in Oakland, and here lead in soil, like many other environmental issues, exposes low-income communities of color far more than other populations. So here you see maps of, can you see my cursor when I do this? Okay. So here you see maps of soil lead in Oakland, and you'll see that the higher levels of soil lead, here again, greater than 400, is correlated with communities of color, people living in poverty, and high blood lead levels. So soil lead and blood lead, there's an argument that they impact, right? That soil lead will impact blood lead. So that's what we see in these maps. And these unjust patterns occur in many places, and it must not continue. We can and must do better. So that's why we're here. I want to just say that lead isn't the only contaminant of concern. It's relatively easy to test for, meaning we have some rapid screening measures. So we use an X-ray fluorescence device to tell you a pretty accurate value for lead and arsenic, cadmium, copper, and zinc, all these metals. Other contaminants you see on this list, like PAHs, polycyclic aromatic hydrocarbons, and dioxins, these are all organic contaminants, which means they're an organic molecule. Doesn't mean certified California organic. They're not inorganic metal, and they're much harder and more expensive to test for, but there's all these toxins from all of these sources. And so we sort of use lead as a proxy, but it's not the only one to consider. And these common sources are paint and traffic, treated lumber, burning waste, sewage sludge could be a source too. So all of these are important to consider. So these are these historical sources. We call these the legacy sources of lead. If they landed in your soil, they tend to stay there. But I want to point out that there are ongoing sources too, which are dusts in the atmosphere. And even though our lead use has decreased over time and our atmosphere is far, far cleaner than it's been in the past, what you see here are these cyclical seasonal cycles where you see high soil in the atmosphere in the summers and lower in the winters, and you see high lead in the atmosphere in the summers, lower in the winters. And this pattern has been tracked in multiple cities for many, many years. And I think it's important to realize that dust and airborne contaminants are really important to consider. And so deterioration of paint can be an ongoing source from infrastructure. My building in Crown Heights is peeling very high lead paint into the backyard, and I think everyone should be aware what's our new or ongoing sources that could contaminate your garden. 4 to 5 million tons of lead were released to the US environment from gasoline emissions. And soil lead is also proportional to highway traffic flow. So important to think about all these sources. And as I said, this image shows suspended more dust in the atmosphere in the summers where it's drier, more lead comes with that dust as well. I'm trying to read the chat. Someone asked if the levels of lead in a population are representative of levels of other toxins. it's hard. So we're talking about, contaminants in the environment and then contaminants in the human body. They don't necessarily go one-to-one. It's hard to have those correlations. I'm really talking about lead in soil. And if there's lead there, we can know that, and it's a good idea to deal with it. Again, as I was saying, it's harder to test for some of these other contaminants, but they may or may not be there. So lead is a good proxy for that. Okay, someone was asking about plants. We're gonna get there. Okay, but talking about lead in the environment versus the human body, what you see in the next figure is the same seasonal. Oh, come on. The same seasonal high dust in the atmosphere in the summer months, as you see here. Also coming right behind that is high lead in blood. So I was saying this correlation between blood lead and soil lead has been argued by many researchers for a long time, but this is not the dominant narrative or explanation used by most departments of health. Most people from the human epidemiological perspective look to lead paint, but there's many researchers I've been looking to, and so I have sources cited here if you're curious, or you can ask me more about it. You can't ignore the issue of lead in soil. If it's there, it is a potential exposure pathway. It may be exposing people, and we see these correlations that should be, that seem to be indicative of more exposure. Okay, so that's sort of this argument that isn't, right, with sort of soil lead is sort of ignored as the source by many, but not all. And so I bring this here to hope that you all can pay attention to it as well. Okay, so what do? We know it's there. We talked about how it got there, ongoing sources. All right. I can't see all your faces or hands, but I sort of ask this. This is a really common question we get all the time. Can we remove lead from soil? And can plants help us do this, AKA phytoextraction? Anyone heard of this? A lot of people think, oh, you can plant sunflowers. It's going to be amazing. Sunflowers are amazing. They're wonderful plants. They will not suck up lead from your soil. Okay, so, oh, I'm annotating. I don't know what happened here. Okay, so sunflowers are great. They won't suck up lead from your soil, and I'll talk a little bit about why these misconceptions are common. There was some research that showed if you add some materials to the soil to make the lead more mobile, sunflowers will suck up more, but then it also leaches to groundwater, and you have a bigger environmental issue. So the answer is no, not safely. But the good news is sunflowers and many other plants don't take up a lot of lead from their roots. So crops are usually safe. We'll talk more about that. Okay, another question. Can we add amendments to make lead less toxic or less bioavailable? That's less harmful on the human system. There's a lot of research that shows adding compost, fish bones, sources of phosphorus, that they can do this, but it's tricky. It's not a guarantee that you're going to it's not a guarantee that you're going to change the form of lead in soil by adding an amendment. It can happen, but there's also many different lab techniques, and there's not a lot of agreement. So unclear. Right, so I just said testing methods are disputed. It's also really important that arsenic is another contaminant that's pretty common. And if you add phosphorus, the lead may be less available, arsenic may be more available. You get some issues. So adding compost is great for soil, and it can overall help dilute the concentration of lead, but it's not going to guarantee fix your issue. Finally, can you dig it up and remove it? And absolutely, if money's not an issue. But as we know, if what's happening in Red Hook, it's going to cost something like $100 million to remove the contaminated soil of the ball fields. Money to remove all the soil and put the issue elsewhere. So the other question is, can you cover it? And that is very frequently, done inadvertently. But I listen to many researchers who suggest that this is a really good way to limit exposure. And here you see a geotextile or permeable fabric, so that water can drain through. It's a really good way to limit exposure that's inexpensive. So cap and cover, we're all pro, as long as you maintain that cover and ideally, alert future land users to what you've done, that there could be contaminants below. I don't know how many of you have been in a garden and you're like, oh, what's this? Let me go dig it up. I have done it. Now you know, don't go digging below and assuming it's free from contaminants. Assume contaminants are there and stay safe. Okay, So one question is, where do you get clean soil? Obviously, GreenThumb can provide it, but I'll talk more about that later too, and some of the research I've been involved in. I had to show this one because I'm proud of it. This took me about 6 years to put together to look at all the different forms that lead can be in. And what you see at the top here is these are lead sinks. These are the parts of soil associated with. So you see solid phases like the clays and the sands, and lead can be literally part of these minerals, or it can be right on the particle surfaces, or it can be absorbed to microbes and soil organic matter, or it can enter solution and move around and enter plant roots. And so it sort of goes from this continuum from the solid to the liquid phases and up to plant roots, and it has to undergo all of these processes to do so: desorption, diffusion through solution, then it likely gets sorbed at a new site, and only then can it be absorbed by roots. And so there's these different phases of lead, there's these processes going on, and then there's all these properties of soil. So some of these are very standard that you test for. Cation exchange capacity you do when you're looking at nutrient availability, how much clays, carbonates, carbonates, I don't know why I did that, come on. Carbonates, iron and manganese oxides are less, and phosphates you can also test for them less commonly, and soil organic matter. Anyway, all of these properties are really important determining how mobile lead is. So if there's in general a lot of all of these, a high content, your lead is going to be less mobile. And if you have a lower content, your lead is likely to be more mobile, meaning more likely to move through solution and enter plant roots. That's why all of these properties are so important to monitor. pH is tricky. When it's pretty near neutral, lead is less mobile. If it's really high pH, meaning really alkaline, can be more mobile, or really low, really acidic, can be more mobile. So this is why it's complex. All of this is going on. And one simple snapshot of a soil doesn't even tell you what's happening as it changes over time, seasonally, with new plants. So the reason why there's misconceptions. But here we are. Okay, so what do we do about all of it? Right, I'm telling you misconceptions, I'm telling you got here, I'm telling you there's these things that aren't so great and it's confusing, but there are things you can do. And so now that we're in the time of COVID, I want to say I work closely with people from Cornell, and a lot of these slides came from collaborators there. And first and foremost, we need to grow healthy food, and we need to know that soil can contain lead or other toxicants. So be cautious about planting directly in the ground. If the soil has been in a site for a long time, likely to have accumulated some contaminants. This is why, especially if or when soil testing isn't available, we use raised beds, or use containers, or you use some newer growing medium, clean soil and compost. Another key thing to keep in mind, keep dust off of people and plants. I already told you how the dust can contain more lead. That can contaminate your body and the plants. So limit dust. Good ways to do that are to cover any bare soil using mulch and pathways. I'll show you some data on this. It really works. It does something. Okay, and then wash your vegetables. Wash them thoroughly. Remove your soil particles. Ideally, if the soil doesn't have contaminants, I think there's good stuff in there for your body, but if there's potential contaminants, just wash it off thoroughly. And then now, remember safe social distancing practices and be cautious about sharing tools and supplies. And I'm happy to share these slides, but there's also a ton of information hubs out here. So these are all for the state from Cornell, but I want you to have these links. So there's other resources for growers, Cornell garden-based learning, the Healthy Soils, Healthy Community projects. You're not alone. There's resources. There are ways to do this very safely. Okay, so other things that people ask are about testing quite often. Someone just asked, is clean soil brought from source also free from other toxic contaminants besides lead? I wish that every bagged soil in a store were regulated and had a little label for the contaminant levels. This is something I would like to see happen in my lifetime, all our lifetimes. I really want this to exist. Right now, we don't have that. You know, the way that the nutrient levels are put now on fertilizers, we have an unregulated market in terms of contaminants. I think we should be able to do that, especially with the screening tool I mentioned that can quickly test for metals. If you're interested in this, I want to work on it. I'm trying to make it happen. So we don't have a guarantee, but I will say that I've tested many different soils from the stores, and vast majority are free from contaminants. So There's always some risk involved, but you can generally assume that the products are being tested. What did I miss here too with
And
kale?
then Sarah, there is a couple of other questions. Do you want to go through them now, or do you want to wait till the end for those?
Planting a plant. Yeah, let me look back. Thank you.
So
Go ahead.
I've compiled them here so I can read them from you. I think Natalia asked first, does replanting a plant on potentially contaminated soil to a raised bed with new soil reduce the amount of contaminants on the plant? And how long should we wait until we harvest from that replanted plant?
That's a great question. And one thing I try to do is empower people to also trust their senses, because there's never one clear right answer. Oh, if you wait X amount of time, then you're fine, right? Like with all of these things, it's like, well, it depends. If you're able to remove all the soil from the roots of this plant and replant it, that's fantastic. Depending on what type of plant it is, it may have more or less of an ability to what we call, absorb lead into and then translocate it into above ground biomass, although limiting that. So my sense is if you can transplant, remove as much soil as possible, put it into new soil, your risks are lower than keeping it in that other soil. The big risk you're minimizing too is the potential for dust or splash soil particles landing on that plant. So if it's surrounded by new clean soil, the dust that may land is going to be freer from contaminants. So I'm more concerned about the surface of the plants really than the uptake. And the other thing to know, and we'll talk more about this, is that most uptake, if it happens at all, it's in the roots. So you be more careful with root crops and leafy greens.
And then there was another question. Thank you for that. That was really great. Also, Stella asked about, I think when you were talking about phyto extraction, if kale works as a phyto extraction plant.
There's no effective phytoextractor for. Sorry. So they can, some plants like kales and members of the brassica family will uptake more lead than others, but the levels we're talking about are more than you want to eat, but less than you need to actually remove lead from the soil. So in order to remove lead from soil, there's this 1,000 million in the above ground biomass. Very, and I did a review paper on this. It's coming out soon. It just got accepted for publication. That's where that complicated image is from. So I'm happy to share all these data. I did a review of literature, and I'm fine if there's ever any plants that can take up over 1,000 parts per million. The really common factor that they all have in common is that the soil lead is easily over 1,000 parts per million too. So it's extremely high soil lead. You can get more uptake, but people should not be planting plants in this extremely high soil lead. They should be covering it. I'm worried about any humans being exposed in that process. Try to remove that limited amount, just cover it. So does that answer the question? I hate bringing bad news, but we have to know the reality here.
That's great. Yeah, it's good to be rooted in reality about this.
I love this question about mushrooms. We love mushrooms. Mushrooms are amazing. Mushrooms can take up some more lead. Again, not enough to remediate the soil. They got their, like through their mycelial, one cell thick networks, they can move some of these atoms, and then they can accumulate in the fruiting bodies. Again, not enough to remove all the lead you want from the soil, but more than you want to consume. So be very careful about growing mushrooms in lead contaminated soil. I think they've been shown to be good at breaking down these organic contaminants and hydrocarbons, but there's mixed results on that too. So if you're looking to, I don't think it's a good idea to try to remove contaminants, not from a safety standpoint. And it's a great idea to grow mushrooms, just grow them in clean soil and kale. Charcoal. Interesting. So charcoal and biochar is something that people look to a lot. And biochar is basically this partially combusted organic matter. An interesting thing about biochar, like we're saying, it's like a totally unregulated market. There's many different forms of biochar. So you don't always know what you're getting and what works better than something else. I've seen some biochar is fantastic for your soil health. I love that. I would love to do some more controlled studies with biochar. I've been talking to a biochar association about that. I think it's great. I don't think it's going to remove lead. There's some indication that it could change the form of lead, like we were saying with when you add phosphorus and compost. That could be helpful, but again, it's not a permanent solution. So all of these things are great amendments. Just they're not going to remove the element that is strongly bound to those soil particles. Is that all the questions for now?
I think that there was one more question on recommended soil. Do you have any like specific soils that you recommend that you can buy, that gardeners can buy at a store?
There's a lot of brands out there. I don't have one that I endorse. So I feel, there's ones that I've used, but I'm not an expert on which does better. I've heard a lot of different things from different people, what they prefer. So that's really your preference about the growing medium you like. I am doing research studying newly constructed soils, but I'll get to that a little later. So with that, to go back, oh, you're welcome. Go back, people ask a lot of questions about testing. And the first thing I'm going to say right now is that all the labs I've been in touch with and their networks, labs are closed currently. So they may reopen very soon. I've worked at the Brooklyn College lab, soon to work with Cornell's lab. They're both fantastic. So hopefully soon you can send your samples to labs. But people want to know, should they test their soil? And all of these are important questions to think about. If you want to test your soil, you want to think about where you are, the site history, the quality of the soils and the plants that are already growing there. And then people want to ask, how do you collect samples? And so there's instructions on the Brooklyn College website for soil testing. But again, there's no one right way. So the best thing you want to do is generally take a composite. You take a mixture. So if you have one bed, you take a number of scoops from the surface down to about 6 inches. You want to get what's on the surface and down to the, most of the rooting depth, mix them all together, and then take about 1 cup of soil out of that. You label that in a baggie, make sure you have the right ID, and you send that in. You'd want to do each bed differently. You want to do each bed or separately from a walkway, and you sort of do your best to try to get what can be represented. It's impossible to be fully representative of any site, but you do your best. And that's why you sort of take that average, so you're not just getting one read from one area of one bed. That one number tells you what's right there, but that can vary widely throughout a garden. So then you can think about where to send the samples. Again, for metals, I think it's reliable to use an XRF test. It's not the gold standard which is digestion or using a mass spectrometer. That can be much more expensive, but XRF tests are good. And then you want to think about what the results mean and what are these levels. And I talked about 400 parts per million for lead. There's standards for all of them. But again, right now, I bring this up so that you have these questions at your disposal. Hopefully you can think about them later. But right now, you can't send your soils into a lab. So what you should do, even when you can test, is and use strategies to reduce exposure. So that's what I'm going to go over now. Yeah, my take-home message here is keep asking these questions and reach out to Brooklyn College or Cornell or any lab you choose in the near future. So I kind of went over this, but choose the spots in your garden. And as I've mentioned before, manage your soil pH, your nutrient levels. But still focusing on healthy gardening practices is the best choice. Okay. So I don't know if some of you have seen this image. This was put together by Cornell and the New York State Department of Health with GreenThumb many years ago. And they went through all the research and found that these are the 10 best practices for healthy gardening. There's others, but they sort of encompass all of this. And they're all based in research. And so you can read this, you can download this image, you can share it. It's translated in Spanish. I don't know, I think that's there may be other languages that it's also translated in. But I'm going to go through these, and this may be a review for many of you, but I want to show a little bit why these practices are so important. So first of all, number one, use clean soil and compost. I think we've made that clear. And try to get it from a reliable source or consider testing when that's available. But in addition to just not having the contaminants, if you do have more organic matter and you add this to a soil, this can dilute and absorb contaminants, form these strong complexes or bonds, limits the availability of contaminants to plant roots, can improve soil aggregation, its structure and its fertility, and reduce dust. So there's all these good reasons to use clean soil and compost. How much to add and what compost mixtures are the best in existing soils or new soils, that's a lot of the research I've been involved with, and I really prefer to do this research in partnership with people doing the work every day. So you have my contact info if you're interested in joining part of any of this. Stay in touch. And I'll just show you a little bit about that, which is, and I'm not sure if you're familiar with the New York City Mayor's Office of Environmental Remediation's Clean Soil Bank. We started a first pilot study in 2014, and OER, the Office of Environmental Remediation, oversees development sites that excavate a lot of sediments. Sediments are just these inorganic sands and silts. They're lacking organic matter. It's the deep materials below our surface. And then they found that tons of them are really, really clean, but they lack organic matter, so we mix them with compost. In our first study, this was provided by the Gowanus Canal Conservancy. We brought them to GreenThumb gardens and one managed by BQLT, and we did a whole study. And we found, here's images of the beds at East New York Farms in the summer of 2015, that they create a viable growing medium, and they're suitable for edible crops. At least 33% compost was adequate compared to the control soil that was provided by GreenThumb. Crops were free from contamination when the surrounding environment was contaminated. Soil metals began low, stayed low, and this is what it looks like. This is where these materials come from, these sediments. And here's some images of a big dump truck being brought to the New York Hall of Science. We mix them with compost. You put them in your beds, and we have, you've got a garden. So these are the kinds of experiments we're going to keep doing, looking at different compost sources and types and other ways to store carbon and, mitigate climate change with these and enhance. So eventually, and especially once things pick up again, you may be able to get access to these soils. Right now, everything's on hold. So that's one, use clean soil, use raised beds. That's a way to show that this new soil is important. You don't use the existing soil in the garden in your raised beds. So just make sure that the materials in your plants are not contaminated. Treated lumber is a big question because it used to be treated with arsenic and copper, and that may have changed. So people have questions about that, but in general, try to stay away from it. And we're building some beds with young people. I mean, it's a great thing to do. It's really fun. Oops. Go back. Okay. I mentioned this before, covering or mulching soil. You can use cover crops, you can use mulch, you can use straw, you can use anything. And everyone says do this, and you're like, oh, does it really make a difference? Well, here I've got this graph from a study we've been doing in a GreenThumb garden that shows on the left here, you've got soils with high lead. It had more like 900 parts per million of lead, a lot of lead in that soil. And we found it in a garden and moved it from gardener use. My screen is over. Okay. And what we did was we grew lettuce in the high lead soil and we grew lettuce in a low lead soil. And then we did all these different treatments, which means we grew the lettuce in bare soil, we grew it under a little mini hoop house that also had mulch. So that limited anything from the atmosphere and any splash. We grew it under a mulch, so to limit splash, but it was still exposed to the atmosphere. We also grew it in a greenhouse. And so that's the treatments we did for the high lead soil. And then we had all the same treatments for the low lead soil. And we compared them to lettuces we purchased from 10 grocery stores around New York City. It's all in Brooklyn, actually. And what we found here is that in the high lead soil without any protection, and these were all washed, there was still a lot of lead on those lettuces. But under the hoop house, limiting splash and deposition, or rain or dry or wet deposition from the atmosphere, that was limited. And here's the safety threshold set by the European Union. So much better. Again, with mulch, much better. And in a greenhouse, which limited both splash, any deposition or splash from the atmosphere, it was really low. So you can grow lettuce in high lead soil and not necessarily have it on your plant, right? Limiting splash and deposition of any kind. Obviously here, growing in low lead is much better. Here's the same safety threshold. All the samples, no matter what treatment, even though they were in the garden outside surrounded by the high lead soils, they were all safe. But no, they're still a little higher than what you might find in the grocery store or in the greenhouse, right? Our urban environments can add some dust and some lead, but they were still safe. So this is, to me, like the data shows, limit your splash, cover your soils. It makes a big difference. Any questions about this one? I was going to say, in case it wasn't clear, we repeated the same study. We did the same design in a GreenThumb garden in Brooklyn and in Ithaca. And I mentioned this before too, but maintaining soil nutrients and pH. What you see here is soil pH, and here's around neutral. And if it gets very acidic, arsenic may be really limited. How much extractable or how much metal can go in the soil solution. Arsenic is limited, but starts to really increase as you raise pH. And lead is really acidic, is really mobile in acidic soils and decreases as the pH gets more neutral. You don't see what's happening over here, but it can increase again when it gets really high. So same thing with cadmium. So keeping it around neutral, 6.5, 7.5 is your best bet. So it really makes a difference. Okay. And then putting a barrier under play areas, again, separating that soil below so there's no mixing. People often ask me this question, can plant roots, go down below the barrier and take up the lead? And as I've explained, most plant roots do not take up a lot of lead. They can find their way, that fabric gets broken down. The roots will make their way through, but under most conditions, the lead is not going to be very mobile. So putting a barrier just helps prevent that physical mixing. If there's no barrier, you might dig down and mix by. Try to limit that. And again, it can ideally alert future users not to dig below that barrier. Children are most at risk, so keep an eye on them. And lead can affect every part of the body, especially the brain, especially for children. So we just keep an eye and make sure they're not putting their hands, which touch the soil, in their mouth. Here's in some of those beds that we built. This was at a NYCHA community in Astoria. This was our barrier. We just used sediment to try to demarcate the difference between the surrounding soil and what was right there. And we'll continue to test that over time. Wash your hands. We're all doing that now all the time anyway, but again, removes it from potentially entering your system, and leave the soil in the garden. Try to keep all the dust outside of the house so it's not anything you inhale or get exposed to. And finally, wash and peel produce. So the crop type matters. As I've said, roots and actually carrots and radishes can take up some lead in their core. Not enough to remediate a site, but more than you want to eat. So even if you peel a carrot, there could still be some in there, which is why you want to grow your carrots in a low lead soil. Leafy greens are shown to generally have more, slightly less contaminants than roots, but more than fruits. And that's because they have such small, so all the surface area that the dust can just adhere to. So you really want to wash them carefully. And then fruits are your safest crops to eat, because they have all of these barriers throughout the plant, especially smooth surface like tomatoes. Any dust can be washed off. One more fun data-driven piece of material here. We grew lettuces the next year in those same high lead soils that I'd mentioned previously. And we know that washing helped, but what kind of washing? And here you see we wash with a commercial product, a dilute acetic acid, which is vinegar. Here's unwashed, rinsed with water, and we soaked with water. And here's that safety threshold. And this was all lettuce grown in high lead soil. And what we see is that the lettuce that wasn't washed had high lead. No matter how you washed it, it was lower and safe for consumption. So wash your veggies. You can always get more info. There's tons of info out there on the Cornell websites talking about standards, how they're used. Commercial product soaps are some of those like veggie wash products. Buying for that, but we just kept calling it commercial product. So they all should work. Vinegar works too. Also, GreenThumb should have signs available, but there's a lot of signs out there for the best practices. This is one that put together a lot of people in this legacy lead network. The city lead-free NYC campaign took this same info. This was from the 10 best practices, but kind of condensed to the big ones. So if you're interested in getting more signage, especially for your homes or backyard gardens or people you know, you can reach out to me, try to get you signs. And in the end, my question is how we can keep focusing on the needs and interests of communities who are affected by contamination and other systemic injustices, and how do we try to prevent exposure to lead in soil? So I think we can keep following these best practices on the small scale, keep building new soil, keep sharing knowledge, and then ultimately working, across the city and beyond to all get on the same page about this. So happy to answer more questions.
Maybe I can unmute some of the people on phones so that they can have a chance to ask some questions.
I see one here in the chat on Miracle-Gro, and fertilizers are a really interesting topic. The fertilizers, like Miracle-Gro, should not contain contaminants. So from a contaminant perspective, they're safe. Are they the best things for your soil's health? There's a huge debate in soil science about this. A lot of people swear by these are called inorganic fertilizers. They do give the plants the nutrients they want. Sometimes they're really, really helpful and important. Other people think that if you're adding these nutrients, it kind of it changes the microbial food web, both the micro and macro organisms in the soil. So adding organic, not just inorganic amendments, adding compost, blood meal, even fish bones, like other organic materials will help that food web come alive and give the plants the nutrients they need. So I'm an organic amendment kind of person, but that really depends on your philosophy and your approach.
I'm going to unmute the phone in case they want to ask any questions.
Okay, good talk.
Thank you. Here's other emails. I have my CUNY email up here, but I don't know how long if I'll get access to that forever. So
if anyone on the phones want to ask a question, you are all unmuted, but one at a time. So,
great question here on the lead impact or matter percentages. Anything in regards to soil structure? Really interesting because I've seen some really beautiful fertile soils with really high lead. So I think not necessarily is the answer. You can also see some really dusty, dry, stereotypically contaminated looking soils that have high lead, right? You can imagine the dust runoff from a mining site or a dirty street. So it's not necessarily one-to-one. And that soil structure and organic matter actually, in general, will help keep the lead less mobile. So the water and the nutrients will move through that soil, those soil aggregates, and the plants will take that up and not necessarily take up lead. But could the lead dust land on the plants, and could that lead dust expose someone working in that soil, incidentally inhaling it? That's the risk. But plants and the soils have these good ways of aggregating and keeping the lead out of the plants and out of us too. So I would say the organic matter and soil structure impact or affect the lead behavior more than the lead impacts the soil structure. Mhm.
For community gardeners that are making new raised beds, is there a soil depth? So they would put the landscape fabric down first, or some sort of barrier, and then is there a recommended, depth soil that they would put on?
You want at least enough room for the roots to grow. So one of these, 10 is generally adequate. Double high can be even better. It depends on what you have available in your space. So at least one, absolutely recommend that. It's great. I've seen, the many high ones for people are also fantastic if you can do it. But yeah, minimum, give it a good 6 to 10 inches.
Thank you.